Welcome, ladies and gentlemen. This is video number 3 in our matter unit on physical and chemical properties and physical and chemical changes. So you'll need your notes open to the place for video number 3 for this. So, physical properties versus chemical properties. Well, first off, the word property really being some sort of description about a substance. So a property is a description, describing something about it. And a physical property would be something that you could observe or something that you can measure. So you look at it and you say it's white. Hey, that's a physical property. You feel it and you say it's rough. Great, that is a physical property. You observe it, you measure it. Hardness, color, smell, right? That's another one. Mass is absolutely a physical property because you measure it. Melting point, remember, right? Phase changes, I'm going to be talking about that. Versus chemical properties. Now, chemical properties, they are properties, so they're describing something about the system, about the substance, but they are describing how the substance reacts or how it doesn't react with other substances. So, hey, does this react with oxygen? That is a chemical property versus what it looks like, that is a physical property. For example, a chemical property of copper is that copper reacts with nitric acid, but copper does not react with hydrochloric acid. These are both chemical properties of copper. Notice they are describing the reactivity. That's really the big thing about chemical properties, how they react, versus physical properties, just, hey, what does it look like? You're just observing it, and it's anything that you can tell about that from the simple act of observation. So question, physical and chemical properties. If two substances have different formulas, how will their physical properties compare? How will their chemical properties compare? Well, the key thing here is that I told you that two substances have different formulas. And the fact that I told you that they have different formulas means that they are different substances. So, for example, water versus hydrogen peroxide. They have different formulas. Water is H2O, hydrogen peroxide is H2O2. Different formulas. And as soon as you introduce that idea of different formulas, you know, therefore, that you are talking about different substances, which means that both their physical properties and their chemical properties will both be totally different. Different substances have totally different physical and chemical properties. Not just chemical, but physical as well. Hydrogen peroxide's density is significantly less than that of water. When you look at things like its melting point and its boiling point, they're way different than that of water. And yet, the only thing different in the formula is the addition of one oxygen. But that completely changes both the physical and the chemical properties of the system. So different substances, different properties, both physical and chemical. You change the substance, you are literally changing all of the properties about it. Physical changes versus chemical changes. Now, a physical change, which hopefully you gathered from the lab that we did, is a change, so you are changing the sample in some way, but it alters the substance without changing composition and without changing properties, right? It doesn't change the substance itself. The material is not changed into something new. Now, remember that phase changes fall in this category. Because you take liquid water, you turn it into ice, guess what? It is still water. You haven't changed the substance into something new. It's still water. So a phase change is a physical change. A chemical change, on the other hand, is now a change where you are creating a new substance, one that you did not have before. A new substance is made that has different compositions and different properties. Your original material, you can sometimes get it back if you have a reversible chemical change, but not easily. You have to do something substantial to it to get it back. The substance is changed into a new substance. We are making something totally new that wasn't there before. You are creating a different compound or a different reaction. You're getting stuff out that you did not begin with. So yeah, phase change is always the really, really big one. You're not creating a new substance, it's a physical change. So this is kind of a frequent mistake about physical and chemical changes. You want to remember phase changes are physical changes. Also, a physical change is making a solution. This is 100% a physical change. If you make salt water, it is both salt and water, and it's still both salt and water when you make the solution. Solution, right, this mixture of usually water combined with other things, homogeneous mixture. You haven't changed the water, or in this case the salt, into anything new. It's still water, it's still salt. This is a physical change. It is not a chemical change, not at all. You can get back the salt and you can get back the water. So making a solution is a physical change. There are four, speaking of but if we look at the other hand, chemical changes, there are four telltale signs that you have that a chemical change has occurred. So it's sometimes you can't really look from the outside at a reaction and say, oh, I clearly see the new substance there. I can tell that we're ending with hydrogen peroxide instead of water. You can't really tell that, but there are signs that you've created a new substance that are pretty consistent throughout chemistry. And the first sign that a chemical change has occurred is the transfer of energy. Now, what does that mean? It means that your system, your reaction, has either heated up or cooled down all on its own. Meaning it generated heat, but you did not actually heat it. You didn't put it over a Bunsen burner or put it on a hot plate. It just suddenly it got warm. If you actually think of hand warmers, that's an example of a chemical change, and that's what I'm talking about, where you didn't actually do anything. You just open them up, and suddenly they get hot. So that's what I mean when I say transfer of energy. Also, cold packs that you use if you injured yourself, where you crack them, and then suddenly it gets super cold. That's an example of a sign that a chemical change has occurred. Color change is a telltale sign. You get a new color that you didn't have before. Well, it's probably because you created a new substance with new properties. So color change. Production of a gas. Now this could, you can see this if you see bubbling in a system, because that will be the gas. If you smell something that you didn't smell before, well, you smelled it because it's a gas and it wasn't there before. So bubbling, fizzing, that is a sign that a chemical change has occurred. And then lastly, is what's called precipitation, aka you form a solid from two liquids. So you start with two things that are liquid, they look like liquids, you combine them, and then you actually make this solid that wasn't there before. And you'll know that because it becomes opaque, because that opaque thing, that cloudy thing, that's actually the solid. So if any of these happen, that's actually a sign that a chemical change has taken place and you've created this new substance.